I listened to .NET Rocks, and then they discussed WPF as a new exciting technology. I'm like, well, it's not that new.
Mm-hmm. Hello and welcome to episode 73 of Kodelife Alpha, and it's a shader night, and we're going to be talking again with Mårten, who's over in the pair programming stream. So let's go straight over there and say hello to Mårten. Hi Mårten, how are you?
I'm pretty good.
You're good.
How are you?
Oh, yeah, I think we've both had a very stressful couple of weeks. I know you have, so that's why we've kind of not done much in the way of shader streams over the past couple of weeks, but yeah, I think feel it's time to get back into some shaders.
So what I wonder is, when I go to your stream, I think it doesn't load for me. Am I doing something wrong?
I don't know. Hope not.
I have had problems.
Right. Okay. So hopefully, so we seem to have someone possibly in chat. So. Is everything okay with the audio and video for the person who's in chat? Could you come back?
Yeah, I like to see the chat when I'm
absolutely,
streaming. Yeah. So I'm gonna try another browser.
Yeah.
So no, it's been we're having this huge project at work, and I'm not going to go into that, but we're kind of coming to an end now, and that feels good. But it's getting the ducks in order. It's quite hard sometimes to do so.
Yeah. Are you still having problems? So we had a follow while we were chatting just a moment ago.
It's my fault.
Okay. So Sedum, if you're in chat, thank you for the follow. Have have some electric alpha. We've got electric alpha and hyperspatial hype now working on the pair programming scene. So I wired that up earlier. So that's for you, Sedum, if you are around. Thank you very much for the follow.
Very important stuff.
Yep.
To get.
And this is the kind of thing we want to work on. So I think the idea that we had for this stream was to try and at least go some way towards producing another shader for use on the stream. And I think you suggested something around about fire and smoke. So that sounds very interesting. So
yeah, I mean, we can try to do. I'm thinking maybe we could do some new high. I don't know exactly. I haven't thought about it really, but we could try to make some new, maybe some raid thing. That
yeah, it'd be great.
Raided.
Yeah, it'd be fantastic.
I don't know why. And I thought, since you liked rockets, fire and smoke.
Sounds perfect.
That's kind of how much I thought about it.
Yeah, it sounds perfect for me. As you know, I'm mad about rockets. So we're obviously building the Lego Saturn V on stream as well. So yeah. So cheers everybody. Good evening to everyone. Could you help?
So, so I think doing that. I think we should start a new one.
Okay. Yeah. So obviously this is the on screen at the moment. The shader we've been working on.
Yep.
For a few weeks
I think
now.
this actually looks pretty good, if I'm being honest.
I think it's great, and I keep kind of watching it and seeing the water, kind of the sunlight sparkle off the water every now and again. It's fantastic. So I think this scene in particular, with the mist and the mountains fading into the background, and the beautiful clouds, really kind of is really lovely. So
yeah, I mean, it's quite complex shader, but at least, I mean, it's real time and it's just pretty good, and I think we can be pretty proud of that thing.
Yeah, it's a bit of a shot to come back to the basic shader here. So we're using Kodelife. Let's give a shout out to Kodelife. So this is the ID that we're developing in. It's kind of I guess you call it like a real time ID. You type a line of code, and that line of code immediately is executed and is part of your shader. So you get instant feedback. If you'd like to download Kodelife, it's on hexler.net over here. So Kodelife. They do kind of ask you for a contribution, but you don't have to give one if you don't want to. So all you get is a bit of nagware at the beginning for 5 seconds if you don't contribute some money towards it. But it's great for playing around, messing around with shaders, and highly recommended. So do suggest, if you want to use some of the code that's up on GitHub, you will need Kodelife to open the Kodelife project files that are stored up there. Now, alternatively, if you don't want to do that, we also have a site on Shader Toy. So these are the shaders that we've done that are up on Shader Toy. And so we've got our kind of psychedelic kaleidoscope here, and our spheres, and a couple of versions of the terrain. Our wonderful shiny marble or shiny ball bearing that's orbiting this cube, and then the water and clouds simulation we got here. So with these things, if you click on them, you actually get the code here in Kodelife.
That's what's great about this site, is that I mean, you see something amazing there, and then you can actually open it up and see what do they do, right? And then from there you can sort of experiment and learn from that. I think this is a really this is where I started kind of.
Yeah, and the great thing is you can change this, and it's not affecting my code. It's just like you can play around and fiddle around with it, and then you can copy it, start your own shader, and put your own changes in. Link Slumps, welcome to the stream. Good to see you. I've not seen you for a while.
Link Slumps.
Yeah,
and also this is like, it's a web browser, so this is what I showed the cool kids at work that does web things, that I can also do web stuff.
Yeah,
that is, I can open GL Canvas and write some open GLSL code. That's about what I can do in web. So, but I can pretend to be, I can do things here that most people that does web can't
do. Yeah, absolutely.
Good about
Linksum says you got some medium marks But so you were is this for your uni course, Link Slumps, or your school course? Got some midterm marks, so they weren't that what you wanted. Never mind. University course, okay. Well, it's only midterm, isn't it? So, is this in the US or in Europe? So I know that midterms are a big thing in the US. In Canada, okay. It's probably the same over there. So I don't remember when I was at university there was such a thing as midterms, and we had end of year exams, and that was it. But yeah.
Yeah, it was a while since I met you were in university, but also since I was in university. Things have changed now. One thing that confuses the heck out of me is that they are changing the grades. So you can't compare your grades with you don't know what the grades means because they switch them all up.
Yeah.
It's very confusing.
We never got graded in that sense. You just got kind of I think from what I remember, in the first and second year, you were basically your exam was, do we let you stay on for the next year?
Oh, yeah.
And then the final year, you got then you had your first or your 2-1 or your 2-2.
I see.
But
I guess every country is a little bit different in that sense. What's these O levels people talk about when they are from UK?
Sorry, say again.
O levels.
O levels. Yeah. So O levels don't exist anymore.
Okay.
So there used to be, when I was at school, we had O levels and then A levels. So O levels was what you did when you were 16. A levels, which still do exist, at 18. So O levels, the ordinary level it stands for, and that's been replaced by something called GCSE, which is the General Certificate of Secondary Education.
Very confusing.
So it's the same kind of thing, really, but
changing things. It was working. Keep it.
Yeah. So Slingsum says he got 70s when he's used to 80s. Well, 70s is still pretty good. Must be above average. So.
But as well, sometimes you have these teachers that really like to sort of. We had one teacher at university talk about links up there. His opinion was that he wanted to teach us everything he knew, right? But he's been working with this for like 20 years, and it's hard to cram it into 3 months, everything he knew, right? But he wanted to do that. And of course, many people failed horribly because we couldn't grasp his 20 years of knowledge in 3 months.
The pudding, welcome. Good to see you. The pudding's handle always makes me smile. So have an Alf salute. So the pudding is in the house. Okay then, so we better actually think about writing some code.
Yeah.
Do you think?
So
Links something about bell curves. Don't talk to me about bell curves, Linksums. It's one of my pet hates. Is the idea that no matter what the what you get on your exam, you get fitted to a bell curve. Still, never mind. Let's not go too much into that. Normalization.
Statistics and that's hard to begin with, but it's also hard to apply it to a limited set population.
I mean, it can seem very, very unfair when you apply it to exam results, but I guess they've got to do something to normalise the results. Anyway, so shaders. We've got we're sitting looking at a default Kodelife project with all the kind of colours on it. So. What's the first kind of step that we're going to take? I guess it's going to be a 2D shader we're going to work on. Is that right?
Yeah. I mean, it's possible to make 3D of this, but I think at least a good first step, I think, in general, is to do it in 2D. And then you can start thinking about doing it in 3D later.
Yeah.
But in my head, I'm not sure exactly how to do it, but I kind of wanted to... I'm not sure we're going to end up there, but I kind of want to have like the elf thing. Fire him up with sort of fire and get him sort of fly by the screen with fire coming out of his shoes or whatever.
It sounds fantastic. Yeah,
that's kind of how I thought about it. I'm not sure if we're going to get there, but that's how we can try to do it. I think.
It's part of the fun of the stream is we got a basic idea of what we want to do, and we'll see. Yeah. Sometimes it turns out better than we thought, doesn't it? So let's see what happens. We'll get something by the end of it.
For that thing, I think we need to define some fire. I think that is the first step.
Right.
And I think a good start is to once again use random noise, as we've been doing many, many times so far.
Yeah.
many times. We defined the mountain ranges using random noise, and then we defined the clouds using random noise. And I think fire is also probably random noise applied over again. So I think we should add a noise texture.
Okay, so right, textures, they live under parameters, don't they?
It's on the shader states, I believe.
Shader stage, that's it, yes. The texture one.
You can remove those textures.
Yeah, we'll get rid of those. Hopefully you can see what I'm doing. It's just behind me, but there's just down here in Kodelife, there's where the textures live, and I've just deleted those. We should have.
You can click the plus sign there up to the right.
Yeah. Up here, there.
Yes.
And we have the built-in.
And then we have noise.
That's it. Okay, I'll try and raise it up a bit. So we're working over here now. We've got a noise one. We're going to change that noise one variable to texture 0.
Yeah, that's usually a good starting point.
And we're going to spell texture correctly. Luckily, you probably can't see that I spelled it completely wrong. Resolution we're going to up. It's 500, is it?
512 times 512 is usually
512. Okay. So I'm learning something here.
Yeah. And I think I'm just guessing a good noise is not white. I think a good noise is the cellular noise.
Yes, we found that was quite good for the clouds, wasn't it? The cellular.
Yeah. So I think a cellular noise could probably work here. I mean, we can
behind me, unfortunately, we've chosen cellular from this.
Is this C? Is Linklabs asking? It's kind of C. It's GLSL, which is a lot like C.
Yeah, very C-like.
Except we cannot allocate memory and we can't do recursion. But we have some nifty ways to sort of manipulate the vectors. We might show it later. I think if you think C to 98%, and then you remove things like memory allocations.
It's got these really nice vec data types. So a 4-column vector, a 3-column vector, 2-column vector. Yeah, so it's really nice.
Basically C with vector literals. No pointers. No pointers. No, hate pointers. Pointers. We don't do it here.
Yeah. And I think we kind of every stream we kind of say this, but this program that you write is defining the color of 1 pixel.
Yeah.
But it gets executed for every pixel on your canvas. So we're going to up our kind of resolution to I think it was 1960 by something in a moment. So every pixel is processed through this program, and it's all running massively parallel on your GPU.
Yeah. So like you're saying, basically the program is we're given a coordinate, which is basically the pixel coordinate on the screen, and our mission in life is to produce the color of that pixel. How we do it, that's what our program does. So and sometimes we write the ray marchers, and sometimes we write the fire noise generators.
Yeah.
So if you look at this random noise here, I think we don't want to clamp. We probably want to
repeat. Yeah.
Repeat. Repeat is a little bit bad because it should be mirrored repeat, but we can if that becomes a problem, we can sort of fix it later.
So I'll just move this over the side. So that repeat. Oops, just a second. Let me try and show that repeat. Oops. Doesn't want to. There it is.
It means that when we sample outside the pixel, outside the texture, we get another copy of the texture with that offset kind of.
And that's set down here.
We can show that what that does.
Yeah, so it's just down here in Kodelife. Fortunately, it's sitting behind me, but never mind.
We can actually show that. So I think we should make. This is what I do now. We make a noise function.
Okay. I can't remember the resolution that we need here.
The resolution is in product. That's usually 1920 times 1200.
1920 1200. That's right. I'm just going to save at this point. Save as, and we're going to call this Codebase Alpha 10.
Yeah, this IDE is very good, but sometimes when you write a loop, it crashes.
Yeah. So we're a bit kind of paranoid about saving. So
yeah,
there we go.
So if you make a new function, I would suggest calling that the noise function. And that returns a float, which is the random noise. And it takes as an input parameter a 2D coordinate, because this is a 2D noise function. So
we have vec2 in there.
Yeah, vec2, yes.
That's a 2-column vector, as I say. That's a position, yeah.
Yeah.
We call that pos. We're kind of getting a bit of a design language or a program, just some kind of shorthand names for various variable concepts. So pos, or pos or p, it's the kind of thing we can use.
They have kind of idioms here, and then what we do here is we sample the texture that we can use using the texture function, and you can actually return here, but do what texture. And the first argument to the texture function is the texture. So I think that was texture 0, right?
Texture 0, yeah. So this is one of these uniforms which are up here. So you can see texture 0, sampler 2D texture 0 here. These uniforms are basically inputs, and they're kind of built into the IDE, really.
And then you give a position to the texture. Now, it's also complaining that the types don't match because this returns vector 4.
Mm-hmm.
So you just sample the x coordinate here.
So in order to do that, we can just do .x.
Yes, they're all the same here.
Yeah.
Now, what you can do now is in your program here, you can in your main function, you can call the noise function and get the random number. I would do it below UV.
Okay. And for noise? And we're going to send in UV.
Coordinate.
Yeah.
And then we initialize vec3 call. This is how I do it, at least. So this is our color that we're going to produce. And we can just initialize with n.
With n, okay.
Yeah.
Okay.
And then the frag color now we should initialize with the call and then leave 1. So these are one of the nice features of GLSL when you have a vec3 plus a normal float, it becomes so now we see the noise here.
Yeah.
So let's go back here to the shader stage and see if we can sort of repeat what these different options do. So if you change repeat to clamp.
Okay. So you can see that's now kind of confined to that corner up top there, and then you get these weird kind of lines.
And now we see a problem here with this thing is that it should look like a square, but it's not a square.
Mm.
So we need to sort of compensate for the ratio of the screen. And that is kind of something at least I no longer think about how I write it, I just write it. So you multiply the x coordinate of UV.
Yeah.
And equal sign. And then you take the resolution, which is it contains the resolution of the screen. And you take the x-axis.
Yeah. Divide it by
the y-axis.
So now we get a square. Excellent.
Yes. So very good. Now, but the thing is, we only get a square in the top where the coordinates are positive. In other quadrants, we are getting the last row or the last column or last row.
Yeah.
So that's the purpose of changing repeat from clamp. So if you change clamp to repeat.
So I'm just going to change that. See, it's down here, so we get repeat, and then repeat here.
Now it's repeated in x-axis.
And the y-axis.
Yes.
Okay.
And what we also want to do in order to make this work is we also want to put on the filter, so it's linear filtering.
Okay, I'll just show you that as well. So those filters are underneath the wrap, so linear filtering like that. Okay.
It doesn't become so much different here, but that's when we're going to zoom in this texture later. It's going to make a difference. So this is cellular noise, apparently.
Wow. You can start to see there are some cell-like, if you kind of squint, there are some cell-like structures in there, aren't there?
So what you can do is you can zoom in this thing. So you multiply the UV coordinate by a number lower than 1. So before you sample the noise function, you multiply UV with a number. Before you sample, before you call the noise function.
So a number less than 1, yeah. 0.1?
Yeah, so 0.1, for example. So remove UV 0.1.
Okay, yeah, so we definitely, yeah.
So now we zoomed in here, right? We can see, and if you take 0 or 0.1.
Yeah.
That's right. Yeah.
Yeah,
so
0.01.
We can see, and we can see if the linear interpolation wasn't there, it would be sharp edges. And sometimes we want that, but for what we are going to do today, we don't want that.
Yeah.
We want the linear interpolation. So what we've done so far when we're doing these things is that we are reading the pixel values, and then we are increasing the frequency and lowering the amplitude and add it again and again. This is what we've done so far.
Yeah.
But before we start doing that, I think what we should do is but we should make sure that the texture function, noise function, produces a value between -1 and 1.
Yeah.
So it's kind of So the way you do it, for example, is you multiply this texture value by 2.
The whole thing, yeah, by 2.
Yes. Because it goes between 0 and 1. So we multiply by 2, then it goes between 0 and 2. And then we subtract by 1.
Yeah.
And if we change the zoom level now, we can see how it looks.
Yeah. So you want to go like that? What zoom level would you like?
That's fine.
Yeah.
0.5 perhaps we can see.
0.5. Yeah.
Here we see a little bit of visual artifacts here. But that's okay if you zoom in to 0.1 again. That's a little bit unfortunate.
Yeah.
We cannot see the axis here.
Yeah.
And that is because if the text was flipped, right, mirrored, then that artifact would be reduced.
Yeah.
But we can just work with that and doing offset.
As if you can see, there's a definite straight line here and across.
And that is unfortunate. And you can actually see that in the mountain ranges sometimes when you go, that you get these valleys that looks very, very weird.
Yeah.
Because of that thing. But if you flipped it, but we don't have to do it, but that is something you can certainly do if you want to improve the sort of look. Now, since we're going to repeat this thing, this is often called FBM. I'm not really sure what FBM stands for, but let's make a function that is called FBM. I can Google what FBM stands for.
We can ask the bot. Let's ask the bot.
Yeah, that's good. Yeah.
Ask what does FBM stand for? Let's see if it knows. I don't think it's that footboard measure.
No,
I don't think it's that.
no, I'm pretty sure that's not it.
Oh, so we can. It's found in the follow acronym finder category: science, medicine, engineering. So yeah, it's not that. So it'd be worth googling.
Yeah, it's a very common technique if you look at the shaders,
So
and it's often called FBM.
Is this going to return the float?
Yeah, so it returns float. And you take hello there, Q Macro 99.
Q Macro 99, welcome to the stream. Good to see you. Have some Electric Elf hype. Very nice to see you. Just dropping by to say hi.
Actually, the light. Here we say this lighting effect is also produced by FBM.
Oh, is it? Okay, that's good.
Yeah.
So we're kind of.
This pattern is just coming back over and over again.
Yeah.
It's a pattern that's really reusable.
So function FBM, what does it take?
It takes a position, pos, whatever.
Yeah. Right.
Yeah, and what we do here now is we initialize an aggregator value like a or sum or whatever you want to call it. Maybe sum is a good name. That is equal to 0.
Yeah. So I'm gonna just go through and put the decimal zeros after. Just so we're ready for kind of shader toy. If we move into shader toy, Link Slumps. My interest in pollution control is doing a paper and got a bunch of smoke stack formations up. Pretty cool. Yeah, well, you never know. We might get something like that.
So, so what we want to do now is we want to sort of call the noise function and then increase the frequency by maybe a certain amount and then also reduce the amplitude. So what we've done before is we have these factors that we can call maybe I don't know, frequency or whatever.
Yeah. An amplitude, yeah.
So I would actually, this noise function, I would actually add the value of the noise function to sum directly.
Okay.
This is like 1, yes?
Yeah.
And then instead of float n, you type sum plus equals.
Okay.
Then you need an amplitude, kind of. And that's also started perhaps 1.
Yeah.
And then you
we're going to do some multiplication, aren't we?
Yeah. You multiply the amplitude by this, by amp, for example. I think, yeah, you can take the frequency for now. I think that's okay. Just multiply by frequency. Often you want to apply a little bit of maybe rotation and things like that, but we can start with this simple way of doing it. And let's see now. Where are we?
FBM has no return, so we haven't returned anything yet.
You return the sum here.
Okay, so nothing's changed so far. I'm just going to save this because we're going to.
Instead of calling the noise function, you call the FBM function.
Yeah, so nothing will change at that point because we haven't actually done our looping. So we're going to loop so many times and apply this. We're going to change the frequency and change the amplitude each time we go through the loop, and then that will be kind of aggregated onto the sum. And this is where you can get a crash. So I've just saved at that point.
Yeah, and usually what I do is I put in something to make sure that the program does, because what happens is you might end up in an intermediate state when you write an infinite loop.
Yeah.
And then because this is constantly recompiling and applying it, then sends an infinite loop to the graphics card, and then the graphics card crash, and then the application crash.
Yeah, so I've just put an X there just to make sure it doesn't actually compile, and then we're going to do a for loop, aren't we? So
yeah,
for int I equals 0, I less than. Well, we start off with 1, aren't we?
Yeah.
Plus, yeah, I can remember some of this stuff, even though it's been quite a while since we did this.
Yeah.
And then we're going to do that. So nothing's changed. We should now be able to remove our X.
Yes. And then what you want to do here is that you multiply after this sum plus equals, you multiply the amplitude by 0.5, for example.
So we can halve the amplitude.
Yeah, and maybe we double the frequency.
Double the frequency. So this is once again things we've done before in other in other applications of the string. So
lot of shaders. I think there are 2 dots here in your.
So there are a bit of C#8 syntax.
Oh yeah, ranges.
Yeah.
So what happens now when we change from 1 to 2 in the loop?
Let's try it. Okay, yeah. So we've got more kind of randomness, and it's a shame we've got the artifact through it, but it does, starting to look a bit more like it could be a cloud of smoke.
Let's try 3 then.
Yeah, definitely get in there.
Yeah, so this artifact I think we can fix kind of by making sure that we sample the noise function. We move the center. There are many ways of fixing it, but we can move the center of the noise function a little bit. So if we go up here into the noise function, and then you add to the position minus or plus one half, for example.
Yeah, so that's much better.
Yeah. For example, it reduces the.
Makes it less obvious, doesn't it? It's over here now, but basically,
let's change the frequency to 3 then to see what happens, because then it doesn't match up with the. If you multiply the frequency by 3 instead of 2.
Oh yes, that's much better.
Yeah.
So I love the way that you get this instant feedback. I've just changed that 2 to a 3, and instantly we get the result. And this is where the experimentation comes in.
And this starts to look like something. Let's change from I to 3 to 4.
Okay. We're getting less of an effect now, but there's still something there.
Yeah, but maybe we can live with that.
Yeah.
We can fix this noise function by we can actually implement this mirroring ourselves. So we can actually ensure that we imply that we flip the texture, so we mirror it. It's doable. It's a little bit tricky.
Yeah.
I've done it, but we can start with this thing here and say, okay, we have some kind of random noise now that looks a little bit like cloud, perhaps.
Yeah, if you kind of squint through half-closed eyes, it starts to look like it could be something.
Let's multiply the position again by, for example, UV. If you go 0.1, it's 0.1 instead of 0.1.
Yeah, well, that's much more smoke-like now, isn't it?
Yeah. This starts to look like something. 0.2. Let's change 1 to 2.
Yeah.
Okay. So what you can do now, for example, to sort of improve. Let's see now. So if you I don't know exactly where is the right way to do it, but we can do it in the FBM function. So if you add the time factor to this thing, so we get the movement here.
Do we want to add that to the sum?
No, so it's before maybe the first line in this FBM function.
Yeah.
You add on the y-axis. You add the time factor to it. Plus equals time, something like that. Yeah. So let's see what happens when you play this thing. How does it move?
It goes really quickly, so we need to slow it down a bit.
Yeah, it needs to slow down. Multiply by this lower number there.
We need to slow it down a lot more.
Yeah, it should move in the other direction, right? So you go minus. Fire goes upwards.
There you go. Smoke rising.
Yeah.
Perhaps we should slow it down a bit more, in fact.
Yeah, let's do it. Okay. But it's quite interesting shapes, I think, already.
Yes. The kind of thing that it's almost like a nebula, perhaps as well. You could use this as a basis for kind of a space scene as well.
Yeah. And there is a negative component here that could be interesting as well. It doesn't show, but there is a negative component here that can certainly help. But I mean, it's very. I like it because it has kind of this cloud look, kind of. And the only thing we really did was that we started from some random noise and added, changed the frequency, changed the amplitude, added again and again and again. And
yeah, so we've used the same trick. We've got this kind of smoke-like structure. We've had clouds from that, and we've had mountain ranges and all kinds. And so it's quite amazingly powerful kind of techniques. This FBM kind of concept coming back again and again.
And you can apply this different kind of random noise, the basic like the purling noise and these kind of things. But I think this looks like a good start for us. We can experiment later. Now, the hard part, not really super hard, but is that we are going to we will need to change the color because we want the heat. We want to be hot on below, and then the heat should sort of, as it rises, the heat should then, it should glow hot down at the lower level, and then it should, when it rises, go more gray, right?
Yes.
So, and one way to sort of starting getting there is if you take this float N here.
Down here on 52, yeah.
And then you subtract the. For example, you can subtract the y, the y value. See what happens. Not much.
No.
Maybe we need the original position before we start multiplying the value here, right? So let's move that multiplication inside the FBM function. This this thing.
This thing here, okay.
Yeah, and then you remove it. Now something interesting happened.
Yeah.
I think.
It is changing, isn't it?
Yeah. So it looks.
Yeah, it's fading out. It's really good, that, yeah.
The colors are wrong, but it starts to look a little bit like what we're after, right?
Definitely. It's the smoke is dissipating as it goes up, definitely, yeah.
Yeah. So let's think about it a little bit. So we could imagine that maybe that the heat kind of, so to say, is exponentially diminishing, right? When it's really hot, it quickly dissipates, right?
Yeah. So yeah, Q-Max-Q, it's amazing what you can do with a bit of maths, isn't it? If you check out, I'll just while Q-Macro is not stopping long, so we'll just quickly show you what we did with to generate terrain with this same concept. Just as a quick diversion, so you can see what you can achieve with this idea. This is using basically the same.
Yeah, Q-Macro, I think it's pretty amazing stuff. And actually, there are people that do music as well on Shader Toy, and you generate music using sort of the same techniques that we are doing here.
So this is basically the same. This is purling noise Obviously, there's a few bits and pieces to be added into it to make the snow and the lakes and the forests and the shorelines and things. But it's basically the same concept. It's a noise texture that's been multiplied at an amplitude multiplication and a diminishing frequency, and you get this kind of effect. So yeah, it's quite amazing. It really is.
It's a very powerful technique, really.
Yeah.
Rambling Geek, hello there.
Rambling Geek, I thought you were streaming. Welcome to the stream. Good to see you. Have a salute from Alf. Really good to see you. Okay, so let's get back to where we were. So there's a slight diversion. They're just.
That's fine.
Yeah, so we got our rising smoke.
So I'm thinking maybe we can we run the exponential function, right? We talked about exponential fall off, so we could just say run exp around FBM minus UV and see what happens.
Put an exp there.
Yeah. Interesting. I kind of like it.
Yeah.
So we can sort of make it, if you multiply the position UV line above, and you multiply by 2 perhaps, so we can zoom out a little bit. Bye bye, QMacro99.
Take care, QMacro. Good to see you. Thank you.
So it might be moving a little bit too slow, but I think it looks quite interesting.
Yeah. So we can speed it up a bit.
Yeah. Remove a 0. That's what I do when I want it to go faster. See if that helps.
Very quick then, but yeah, it's kind of boiling up, isn't it then?
Yeah.
A bit too quick, I think, but.
That's a little bit too quick. But I mean, it's starting to look a little bit. 3. Did you say 8? Yeah, well, we can leave it there.
There we go. Let's have 8 and then be stuck with it. This is the problem. You can get bogged down for hours.
Yes, and just tweaking numbers back and forth.
Just tweaking around, yeah.
But that's also what I like about this, that this sort of constant sort of tweaking is possible. Let's multiply by. Let's keep it here. A function that I really started to enjoy personally is the tan h function. This is a favorite function because we want kind of the value that we produce is between 1 and 0. It shouldn't go to infinity. That's hard to deal with.
Yeah.
So, and the exponential function. So a function that I really like is that if you take and put this exponential function inside a tan h.
Yeah.
Function.
So we've done this before as well.
Yeah. So tan h basically is linear around 0, right?
That's right. It's linear around 0, but it basically infinitely approaches kind of 1 and minus 1. Never quite gets there, but yeah.
Yeah. So when the values is so it went around 0-ish. So exponential function has a tendency to go very quickly towards infinity, but now it tends towards 1 instead.
So we came across the hyperbolic tangent quite a lot during the audio streams that we did kind of way back. So yeah, very useful function.
Yes. So now if you take the color here. And you type, instead of n, you type n, 0, 0. Then it's reddish. Which is cool, but it's not really what we want. We want it to be kind of white hot, right?
Yeah.
And so I think what that means is that red, because when it starts to be white hot and then it goes to orange, and then it becomes more red, and then it's off, right?
Yeah.
So if it goes towards orange, that should mean that blue should go towards 0 faster, if that makes sense, right?
Yeah.
And one way to do it is if you say n, n, then it's white, right?
Yeah.
But we can start there. And then you take another very powerful function, which is called the power function, comma 1. So if you take the comma 3 instead, what happens?
Oh, yeah. So the green.
So it starts at white. Let's try 6, perhaps. Yeah, it becomes yellowish. We want it to turn more orangey, but that's a good start. Let's try with the green color now, and we do the power function there as well, perhaps. Now this is experimentation. Maybe comma 3.
Okay.
Yeah. So it starts white. And then
it's going kind of orange. It's kind of very browny orange, and then yeah. So let's try changing this to 3, shall we?
So let's multiply, just for fun, multiply the red color by 1.5, perhaps. See what happens. 1.5.
Oh, yeah.
Okay. Interesting. Let's multiply the green color as well, just to see how that feels. No, not the blue, the green.
Ah, okay. Yes. So that's now getting the kind of effect. It's like, yes, boiling. Yeah, broiling fire.
Yeah, I mean, it's not that bad. We're just tweaking a little bit of on the numbers.
Isn't it astonishing what maths can do? I think if you were if you were kind of given a demonstration as a youngster of what you can do with maths or mathematics, let's say, maybe you would have paid more interest in more attention in class, because it's kind of inspiring that simple mathematical functions can do this. So I can now see not exactly a practical application, but it's a fun application of them.
Yes. So let's multiply the UV coordinate by maybe 4 instead of 2 to zoom out a little bit more. So you multiply in main at line.
Okay,
52, 4.
Ooh.
And let's subtract. Before that, we can subtract the position a little bit. So we can move it downwards. So we kind of have, yeah. So you take uv.y minus 1. I don't know what that will happen. Let's see what happens. That was the wrong direction. Okay, plus 1. Okay, that's a little bit too much. So plus 0.5 perhaps. Once again, random numbers testing.
Yep,
Okay.
certainly got a fire right at the bottom of the screen, haven't we?
Yeah. Let's increase the speed of this thing here, right? So then we 2 perhaps.
It's amazing what you can do, isn't it?
Yeah, I mean, it's not really, the mathematics here is not really mind blowing, but it looks pretty good.
What it looks like is pretty mind blowing, yeah.
Yeah. So and this is why I like this thing, because I mentioned this many times when I talked on the stream, that when I work at my work, I can sit with a cloud formation template for hours and produce a long one, and then in the end it does something which I don't feel is so amazing. It is quite amazing, but it doesn't feel amazing.
Yeah.
And here we're doing a little bit of simplistic math, and it kind of looks like fire. Yeah. Kind of.
60 lines of code as well.
Yeah, I mean, and there are some junk.
There's some junk at the top there, yeah.
So I mean, the real is 30 lines of code is kind of for the real stuff. So we want to have smoke, right?
Yeah.
So how are we gonna do that? Let's
there'll be something fairly similar to what we've done, doesn't it, really?
Let's just try to add this n to the color, just to at line 55. So if you take plus n here, didn't really do the right thing, but
it's interesting though what it's done. It's
yeah.
let's take it off again and see if we get the difference, because sometimes you can't. Yes,
Yeah.
So it's
It made it more grayish and
yeah.
not really. Okay, another thing we can do here, right? N is a number between one, it's very hot, kind of,
Yeah.
and 0 is that it's cold. So what we can use N then to sort of switch between different colors.
Yeah.
So and then we can use the very powerful function called mix. So if you type the mix function here,
Around the vec, yeah.
Yes, mix, and then you type vec31 somewhere there in the beginning. So this is once again testing, right? So vec31, comma, 0, comma, and then you mix using the n value.
So mix at the end, the n at the end, isn't it?
Yes.
There we go, and there's the smoke.
It's interesting, right? It's not really right, but it's interesting at least. Let's change from 1.0 to another value, like 0.3.
So now we get kind of an effect of smoke off there. It's not that pronounced, is it?
0.5.
There we got some smoke coming off it, haven't we?
Yeah. It's not really right. But let's just random. Let's instead of vec3 0, let's put n value there. What happened then?
It's kind of got some smoky effect at the top there.
Yeah. So we can use the pow function here to sort of push the value towards 1. So if you take pow and take 0.5, pow with 0.5.
Ah, okay.
Now it's starting to look a little bit like something. Or? What do you think?
Yeah, I think it does. It's definitely there.
I mean, now we see the structure kind of what is the cloud thing here, and it looks like it's cooling into this grayish mass.
Yes.
Let's just change 1 to 0 to see how that looks. I mean n here, over here.
N.
Sorry.
But here, at the end.
So 0, yeah. 0. So it looks kind of cool, I think. Yeah.
I think that really works, doesn't it?
I mean, it's not that bad. I think it looks quite good on stream.
It does look good on stream, yes.
Because if you just use the gray color, it looks very gray, but the fire gives some kind of color to it, and then it fades off into grayish blackness, kind of, right?
Yeah. Copper Beardy, welcome to the stream. Good to see you.
Hello there. So, I mean, this is a start at least. Let's zoom out a little bit more and see what happens. So if you change 4 to 5, the multiplication on line 52. I want to see the update on the stream. I actually think it looks pretty good.
It does.
Being honest.
Yes, it does, and it's I don't know. The kind of area in the middle here, just below the long line, you can definitely see the cooling happen. There's the bright white fades through yellow to orange, and then we're going up to grey. There's a smoke rises.
And I like that we see the kind of the structure as well, right? There is a kind of a structure to
yes,
the cloud.
Definitely, and that's the cellular random noise that we've got, giving us that kind of structure. It's nice.
Okay. So if you think this is a good enough start, so how do we make this into something for Alf?
Yes, that's kind of Yeah, that's quite hard, I would have said, but hopefully you've got an idea.
I'm thinking we could try some polar to rectangular coordinate transformation.
Okay.
Because I'm thinking we have now flat fire, right? But we kind of want the fire to be spreading out, if you know what I mean.
Yes.
So it starts and then it should spread out. And that is kind of a half, or not a half circle, but that's kind of, in my head, that could be maybe achieved with polar coordination to rectangular coordination and some tweaking, right?
Mm-hmm.
That's what we do.
Oh, the tweaking's the important part, isn't it, really?
Yeah. Not really thinking through, right, how to do it, just trying stuff.
Well, that's it.
So let's see if I can find some polar to coordinates so we don't have to sort of come up with that math ourselves.
Okay.
It's not that hard, though.
We've done it before, in fact, done it on stream before.
We can probably do it. So let's see. Well, if you go from polar rectangle to polar, right? Okay, let's write that function. So that should return a vec2, right?
Yeah.
And it's two polar coordinates, or what you want to call it. And it takes an input, a vec2 as well. And so what we do now is then we want to produce an angle and the radius. The radius is simple. The radius is just the length of the vector, right?
Yeah.
Or pos. And then we take the arctangents. So this is a very nice function. To produce the angle, we do the arctangents. And this is the nice thing about this handles. No, atan. Sorry, atan. And this takes two arguments, pos x and pos y. And then it handles all these problems of which quadrant is it, which is often a big hassle when you do arctangents. And then you return a vec2 that has the radius and the angle.
So Copperbeard, you should appreciate the maths we're doing, or the mathematics, because I know that we're interested in doing some algebra on stream.
So you spelled wrong here. I didn't want to say it, but now I'm saying it anyway. There we go. And then we go to rectangular coordinates.
Okay.
And then the float x is the radius, which is polar.x, right?
Yeah.
Multiplied by the cosine of polar.y. If you don't think it's right.
And this will be multiplied by the sine, won't it?
Yes. I have no idea how this will turn out, by the way. I'm sitting here thinking, I'm trying to guess, but I don't think I can guess.
Yeah, well, we'll see.
Yeah. So what we do then is I suggest that we here we take at line is it line 66, we transform the UV coordinate before that line, right? Maybe we should make it like this. Maybe we should break this out. What we're doing here, we make this we make a fire function which returns the color of fire. I think that's a good idea. So we make it returns a vec3, and you have a fire function, and then it takes input the vec2.
Okay.
And then you move line 74 to line 78 into that function. Because I find it's easy when I have these functions that, because when you start messing with the coordinate system, it can get messy, so to say. And now it's called pos instead of UV.
Yeah.
Right? So. It's a quite nice background to have in the background,
Yeah,
fire.
it's quite warming, isn't it?
Yeah. And then you return the color.
Yeah. So remember what we do. All we actually after that is that colour. You had fun, Copper Birdie, on stream this morning doing some mathematics. That's good. Okay.
And then you initialize vec3 col equals UE. And nothing happened. And that's exactly what we expected, right? Because we just
haven't changed anything, yeah.
So now, before this UV, before we call this fire function, let's transform this UV into the polar coordinate system. So vec2p polar, or whatever you want to call it.
We call it 2 polar, didn't we?
Polar coordinate, I think even. And it needs to be a vec2 instead of a vec.
Yeah. And then pass P in there.
No. Oh, yeah, that's pretty cool though, but not what we wanted.
Interesting though.
Yeah. I think that's also cool about these things. Things happen, and you go like, yeah, this is not what I wanted, but it's something.
Yes, it's amazing how many times that happens. We get something, and sometimes that kind of thing that just happens is really cool.
But also what's nice about this, because usually the way when I program for real, make money, when I do something wrong, it usually crashes and it produces nothing fun at all. And sometimes it produces serious residue that I need to clean up. Here it's just, this looks weird.
Yeah.
Let's do something with that. But the way, what I thought is you transform the UV coordinate into what you do here is if you transform back, take the UV coordinate and transform it back.
Where do you want to do that?
Here, line 79.
Line 79.
UV equals to rect. Oh, I don't know. Remember what you call it.
Oh, it's consistent.
I hope so. And now you have to remove the vec2 here because you already have the vec2.
I've already got UV. Yeah.
And then you just change UV. So it's flipped here. So we did something wrong because if we did it correctly, it shouldn't change at all, right?
Yeah.
So maybe we flip the A tangents thing. That's easy to do. So if you go up to the 2 polar coordinate system and we change pos x, pos y at line 50.
Ooh,
also pretty cool, but not really what we wanted.
There we go. We're back.
Yeah, now we get there. So what we did is we transformed the polar coordinate system and then back again, and that should make no changes.
Yeah.
Okay, so let's just take the position P there and add something to the Y thing value here and see what happens. So at the line 78, make a new level 79. And you P dot Y plus 1.
Okay.
Okay, I'm not sure what happened, but it's interesting.
It seems to have kind of rotated through 45 degrees, haven't we?
Yeah, probably just a simple rotation. Let's multiply it instead by 2 or something like that.
Wow.
Yeah. It's interesting. What happens if you multiply by 0.5? Okay.
Wow. Very odd. with an ugly straight line just there.
It's not really what we wanted, but it's interesting at least.
Yeah.
What happens if we multiply by 1.5 or something like that?
That as well. That's interesting. Yeah, this is quite an interesting kind of effect.
Huh. Interesting. If we go to what happens if we do with the x-axis instead of the y-axis? That was not very fun. If you take plus 1.5.
Ah.
Interesting. Minus.
I mean, it's quite fascinating as it is, isn't it? It's like a fisheye lens effect.
But to be honest, I mean, in some sense, it starts to look a little bit like a rocket thing here, right?
Yeah, if we flipped it.
Yeah, you can take the x. If you take the at line 77, and you multiply the y coordinate by -1, that should flip it.
Yep. So we got kind of like an exhaust.
I mean, we just by random changing here, but it is looking a little bit like an exhaust.
Yes.
So let's make the white thing a little bit less. So if you go up into the fire function here, right, we are adding this +5 to move the fire thing. So if you add at line 64,
Yeah.
75 instead of 0.75 instead of 0.5.
Okay, that's good. Yeah.
Because what I'm thinking is we could maybe use this thing. It's a little bit too extreme. It's kind of, but one way to sort of handle this thing is, right, if we was to use this, is we make sure that this, as when it moves out to the sides here, we multiply the color so it fades out.
Fades quicker, right? Yeah.
So it doesn't go into this very weird. The thing we see right now is quite weird, right?
It's like a tornado, isn't it, going around the outside?
If it was fading out, and if it made it a little bit maybe less extreme somehow. I mean, I think it looks surprisingly good if you're just focusing here
on the middle part of it, yeah.
Because it looks like something that comes out very intense and quite straight, and then it kind of spreads to the sides. It's just that it spreads a little bit too much.
Yeah.
So let's tweak these numbers, this px here, and take instead of 1.5, take 1.0. What happens then? Interesting.
Yeah.
What does 2 mean? I have no idea what this does, by the way. I mean, that looks kind of neat, right?
Yes, it does. What we need to do is, as you say, it needs to fade out so it doesn't get this swirling effect on the outside. No, it's very interesting. It's almost like a whirlpool or a hurricane or something. It looks down from above.
It looks like it.
Or a black hole or something.
And then it starts. Yeah. I mean, we have something here that we can work with, I think. Not really sure how, but so how will we do that?
We almost kind of just want this section, don't we? And you want everything round above here and to the sides to really kind of fade out quite rapidly. So maybe the exponential part of it. Where's that exponential? So that's here, isn't it? We almost want the colours to.
I think it's. So this is just my guess here. Is that these polar coordinates will help us determine the angle,
right?
Because we have the angle here, right?
Mm.
So we can use the angle to sort of determine where we are. I don't think you can see my cursor, but we can use the term angle to determine where we are on the screen, and we want to sort of isolate this part here, right?
Yeah, just this part.
So we have to find those values. So one way to do it is if you take instead of initializing call. Oh, can I borrow the keyboard? No,
yeah, you should be able to. I'll give you control. Yeah. There you go. So your cursor should appear. But we forgot to do that at the start. There you are. So you're.
So yeah. Well, now it comes to the magic stuff here, right? Look at that! Amazing.
It works.
Oh.
You spoiled it then.
And then we take, because P was the angle. And we divide by, that was hard.
I'll do a division for you.
Division character.
There you
go. 6. Is it negative as well? Maybe it is negative. So I'm gonna use this. Yeah. Arc times likely negative, right? Because the angle goes between minus pi and pi, right?
Yes.
So I'm cheating here, and right.
Pi in there, yeah.
So, and this is the area we want to keep, right?
Yes.
So our mission in life
to rotate that around and get a bright area there, yeah.
Is figuring out what is this angle. So let's as usual when I do these things, I randomize stuff. I think I'm going to use the smooth step function. That could actually work for us. Smooth step. I always forget though in what order the arguments comes in smooth step. The arguments are not really consistent. 0, 0, 1 p dot y.
Oh, we're getting there.
What does smooth step do? Well, first I can explain it, but first I need to check that the arguments are coming in the right order. Smooth step is another one of these extremely useful functions. Yes. So there's a chat question, by the way. That's why I'm answering that thing.
Yeah, I saw that.
Yeah. So what smooth step function does is that if p dot y is lower than 0, the smooth step function is 0. If it's greater than 1, it is. If p dot y is greater than 1, it's 1. But then in between, it creates a smooth interpolation between these two values. So it's very useful when we are trying to. Then we can put a lower limit and an upper limit, and kind of create a gradient. Yeah, if that makes sense.
There's something else that comes up in audio work as well.
Yeah, I can imagine that. So p dot y. So at least that's how I thought it was working. There's a lower edge of the Hermite function, upper edge of the Hermite function. Yeah. Okay. So maybe we go here. As usual, some randomization here.
Ooh.
So the thing that is surprising me is I wanted to move. When I changed both of these things, I moved
in the same way, yeah.
Yeah, I wanted to move this part.
This part of it, yeah.
So I thought So that's why I'm reading the manual here.
You've got a manual.
Yeah. That's cheating, I know.
Yeah.
It's a little embarrassing. But let's see here. If I put in 0, it's black. Put in 1, it's white.
Right.
Put in 0.4, it's gray. So we can see that depending on what the value is here, it's kind of it creates this kind of gradient here. But I'm a little bit surprised by this thing here. Plus, can you help me with the plus? Yeah, thank you.
No, interesting. And we actually need to rotate that, don't we, somehow?
No, but it actually makes sense when I think about it. Yeah. This is just me being confused. That's why that's why it's like that. Okay, we can actually. So what we want to do, I'm thinking, loud again. Is we want to create this kind of triangle shape here, right?
That's right, yeah.
But the problem is the smooth type function goes from 0 to 1. But we can, if we combine two smooth type functions,
right,
we can sort of multiply them together. So let's see how does this thing look here? Didn't look right. What's happening? Yeah. 2, 3, 4. Okay, let's change this to 3. No, that didn't work out. 3. So lots of random stuff here going on. Now, okay, so
now we've got the opposite side, haven't we?
Kind of the opposite side, right? So what I'm going to do now is, can you copy this text here?
Okay.
And multiply. And then I flip these things here.
Ooh.
Now we're getting somewhere. I mean, it's not right. I wouldn't say that. But it's getting somewhere.
It's certainly the effect we're after, isn't it? So
yeah, so let's take this thing and multiply. Just multiply this. No. Equal.
There we go. It's amazing, isn't it? It's just astonishing.
Yeah, and the problem here is also that it's kind of it's nice, but it goes a little bit extreme on the
edges,
bottom, right?
Yeah.
But what we do then is that we do a smooth step again. I need a multiplication here. So I'm just going to randomize some numbers again. That didn't work. Let's see how that looks. That didn't look like much. That's okay. Can we comment this thing out here? And I put a semicolon. No? Oh yeah.
To vector it.
Yeah, put the vectoring around this thing here. It kind of has the reverse.
Yeah.
I wanted. So if we change this
1 to 0, yeah.
Okay, and that's a little bit too much. That starts to look maybe like something, right?
Right. Yep. That's starting to bring it in, isn't it?
Yeah. Can I go minus here? Okay, that's something we can work with, right?
Yeah.
So take this thing here and remove the comment there. And now it should disappear into the darkness. So if we multiply here again with this thing here, right?
That's it. So it looks like it's kind of hitting the ground and boiling upwards, isn't it? The cloud, the smoke. So
can you go full screen and we can see?
Yeah. That should be enough, shouldn't it?
I mean, it's not perfect, I think, but it's a start. So
I never. Every time we do one of these streams, I think, I'll get used to this. What we can do with shaders, but I don't think I ever will.
No, you shouldn't. Don't get used to it. It's amazing. I mean, when I look at the fire here, I think it almost looks like it's kind of boiling out of sort of some rocket engine here, right?
It does, very much so, or spilling out of a volcano or something. Yeah.
Yeah. So, and it's just pure random noise applied without too much thinking about it.
Yeah, Copper Beardy agrees with the volcano. It's like a reverse volcano.
What happens if we change this to?
You need to make it symmetrical. So we're in the number tweaking phase at the moment, aren't we?
we are there again.
Oh, okay. So that's looking a lot better. I think that looks pretty correct.
I'm waiting for the stream to catch up here.
Right. Let me hide the editor for you.
I mean, we can at least try to put an elf on top of this thing here and see what happens.
Yeah, why not?
Yeah. I mean, we can certainly continue tweaking on this thing here and sort of make it. But I really actually really like how it kind of boils out, right?
Yes.
It explodes out of this engine. So, what elf figure should we use for this marvelous shader?
Well, we've got a couple available to us. We've got the saluting elf or the hype elf. Maybe the hype elf looks like he's flying more. What do you think? The saluting elf. So we've got the saluting elf. He's standing up. He's looking over to one side, and obviously we've got the pondering elf, and then the hype one. Probably the one to use.
This is a salute going into the space.
Yeah, it could like be. Yeah.
Yeah. How does the bottom look on that?
It's flat, so there's no. It's what you see on the screen is what it is really.
What you see is what you get.
Yeah.
But let's try that one, right?
Yeah.
So what you do now is you take this. This is a PNG, right? We import this as a texture.
Right. So texture 0, yeah? Texture 1, sorry.
Yeah.
Where's the plus sign? That's noise. I still struggle a little bit with this interface.
There's a plus sign.
Yeah, I'm trying to say I can't spot it.
No, it's up there. Parameters 3. It's almost on top.
Oh, there it is. Yeah, there it is.
There you go.
So we want to.
I think it's constant now.
Yeah.
It's confusing enough.
Texture 2D.
Yeah.
Watershed. Yeah, texture 2D.
Yeah. I was experimenting with shared video. It was pretty fun as well. But that's what we're doing now. File. So you specify.
Let's go and find Alf. I'm not sure which one to try. We'll try the big one.
I think the biggest one is the best.
For some reason, he's upside down.
Yeah, but that's easy to fix. We just flip the y-axis. Yeah. I think we probably want to linear. Yeah, linear is good. Clamp is good. Variant sample. That's probably not important.
I'm just going to move it over so you can see his alpha now appeared on the bottom down here.
So what we want to do now is we want to produce the alpha picture and sort of put it on top of our volcano here.
Yep.
So in order to do so, we don't want to distort this thing so once again, we should perhaps take this volcano thing we've done and create we call it Vec3 fire blast, a volcano, whatever you want to call it, and we make this into a function.
Okay. So Vec3
flare, I don't know.
Rocket plume, I don't know. Yeah. We want to take a Vec2 in there, don't we? Of course.
Dragonfly is a good choice. It's a good choice.
And we want to return call.
Yes. And it's not UV, it's P or POS.
Yeah. Yeah. And then we can just say that call is equal. It's going to be Vec.
No, you didn't actually. Vec3 call equals rocket plume. And yeah, there's a misspelling there at line something. 75.
75. Let's pause. I've got another UV somewhere.
It's the red line. Line 79.
Yeah.
So, okay, good. So let's sample. So then you say col here. At line 92, perhaps you type col equals texture 1. And you pass in the UV pos here. No? Oh yeah, .xyz. No,
right.
not there. The texture function returns F4.
XYZ, yeah, that's it. Oh, there's Alf.
You see the ear is funny.
Yeah.
And the reason for that is because how the clamp function works is that it keeps the last column. So because
just repeat it as,
goes into the last column here, that's why it looks like this.
Mm-hmm.
But we can fix all that. So that's that's fixable. Because what we do is just we can make this alpha function, right? So let's make an alpha function, for example, and then we can just make sure that when we sample pixels that are outside the box, so to say, we just make sure that those pixels are transparent.
Right.
And they take a position P or whatever.
We will be consistent and use pos. Okay.
And then you take Vec3 col equals texture 1.
Okay.
And and then you return call. Misspelled. And then there's a UV instead of POS there inside. At line 89.
So there is. Okay.
So now we can fix this problem we're having here. So we can make sure that if POS is how should we do it?
Welcome, Dragonite. Good to see you, and good for your cat for waking you up, so you can join the stream. Good to see you.
How do you do it? How do you do it the best way? That's what I'm thinking. We want it to be I can maybe type some code here.
Yeah, you go ahead.
And we see what happens. Float A. And we use the step function instead. And I need to read the manual for step function as well. That's embarrassing. But I'm always uncertain on exactly which order. Yeah.
See, we want some intelligence. I'll duck.
POS X.
What's your thinking here?
Yeah, so what I want to achieve is kind of a square.
Right.
That is when we're inside. Maybe that's the simplest way to do it actually. When we're inside 0 and 1, it's 1, and when we're outside, it's 0.
0, yeah.
So, and we can probably use the step function for that, and it's probably better. But I'm not going to work on that right now. I'm just sitting here thinking that it must be a better way of doing this.
Well, my philosophy is get it working, and then see if we can make it better.
Yeah, that's not my philosophy.
No.
My philosophy is getting it perfect.
Getting it perfect first time. Yeah.
Get anything done. So anyway, so POS X is I thought I had it.
What do you want?
If this is greater or equal than 0.
Oh, you got it, yeah.
And the and you can type this and.
There you go.
POS X is less than equal to 1. Then we do this question mark. Then it's 1. Otherwise, it's 0.
Yeah.
And then you do the same thing for the x-axis, the y-axis. You can call it float B. I don't know. It does.
Oops. Well, so you didn't manage to copy that then.
Yeah. The thing is, you want to avoid ifs in shader world, but it's not certain this costs so much because branches are calculated. All branches are run often, and then you multiply call by A and B. And now you see the ear disappeared.
Yep. So what we did there is just get rid of that kind of.
Sorry.
So we were just trying to explain what we did there is get rid of that kind of funny artifact where the clamp function on the texture was repeating the ear off to the right all the time.
But we actually should return the transparency. So let's change this into WEC4 instead, because I think that is the correct way to do it. And you take a WEC4 col, instead of vec3 there, right? At line 91.
Yeah.
No, not there. 91.
Yeah.
That's right? Yeah, and you had to remove those things, yes. And then you can select X, Y, Z here instead.
On the alpha, yeah.
Yeah. Because we're going to mix these two images together, and then we want to mix with transparency.
Yeah.
So we want to keep the transparency. Otherwise, look. Okay, so let's rotate out so it's we get the rotation correct now. So before this float A, right? Let's just flip the y-axis. Cos y multiplied by -1. Hopefully that improves the situation.
There it is.
Very good. And let's center it all. So if you go pos y, pos x, eller pos minus, no, not pos x, sorry, I said the wrong thing here. We want to center it, so we want to sort of take pos minus pos equals minus 0.5. Let's try 0.5. See what happens. That's the wrong direction. Plus. No. That's how it works, right? The wrong direction, then that's better.
Centered him and just make him smaller.
Yeah, then you multiply the position by something. So multiply position by 4. Yeah, but we probably need to do it before we do these other things. So you move the line to line 8. Yeah.
Yeah, there he is.
Not there. Yeah, that works too, right? Yep. Good. The rocket plume as well should return.
The vec4.
Yes. So the thing is now is how we do this thing is that you have vec3 col here, and then this there should be vec3.
Right.
But what you return here is vec4. So what we do here is we let this smooth stepping thing. It actually is the then transparency. So you say instead of col multiply that thing, you take float t or float alpha or whatever you want to call it equal the smooth stepping.
Okay.
And then you have to remove the vec3 we have randomly put inside the middle there.
This one here?
Yeah. Yes, and then what you return, you remove line 83. We don't need that anymore. And then you return a vec4. Yes, there. And then you return comma alpha.
Yeah.
So and line 101 is complaining, right? So let's go down there.
Yeah, okay. So that needs to be vec4 there. And our col is a vec4, so we don't need this. Is that right?
Yeah, we need that. Now we're gonna mix these together.
Okay.
So I would say you make a col. Let
you
me
carry on, yeah.
Try to random stuff again. So we're gonna do vec3 col equal the vec3. So now we're gonna do the alpha thing here, alpha blending.
Okay.
Comment this out to begin with. At least that's what I thought I was.
I'll do it, don't worry. I'll do it.
Yeah.
There you go.
And then we take. It's hard, these things.
So Mårten's using obviously a Scandinavian keyboard. So
yeah, it's also a little bit of latency here. Elf color. When I'm typing, it's a bit different here. And then it's an UV.
Okay,
and
right.
then I do a mix here. Between col and elf col.
Okay.
.xyz. But we're going to mix with the transparency. W, right?
Yeah.
So the idea here is if this is 1, we want to keep all
The
of
whole
elf.
of it, yeah.
If it's 0, we want to keep the background color, and if it's something in between, we mix them in between.
Yeah.
Then what we do here is the same thing, but for a rocket call.
Okay, yeah.
Not sure this is the perfect way of doing it, by the way, but I think it's good enough for us. You know what to say? Great is the enemy of good. So no undefined rockets.
Rocket C there, yeah. Whoa!
Getting there.
It certainly is.
Yeah,
Incredible.
I think let's move alpha a little bit up, right?
Need to go a little bit further up, yeah.
So I'm gonna take here and as usual, just and that's also something you have to keep in mind when you read all these cool shaders and you see them choose a number like that's a bit cool, but not exactly what we wanted. When you find these numbers and they are like, wow, how can they be so smart to come up with that exact number to work? I kind of figured they are probably quite smart, a lot of these people, but also think there's a lot of trial and error.
I'm absolutely convinced. It looks great on stream. Well, on my little OBS kind of preview of the stream, it looks really good. That does.
Yeah, it does actually look quite nice. I mean, it would be better if we had kind of a rocket engine here, right?
Yeah.
But that's we can fix that later. But we can keep this kind of for now, right?
Absolutely, yes.
Yeah. So let's make this into a function.
Okay.
This whole thing here. Because if we make it function, then we can make an animation where it just whistles by, right?
Yeah. Not quite sure what to call it.
Rocket Alf.
So this is a Vec3 we're returning, isn't it?
Yes, probably.
And we're still taking in the Vec2 pos.
Maybe we should return Vec 4. Doesn't. It's okay. We start here.
Start there, okay.
And it's usually it's irritating is UV, right? It's pos here.
Yeah.
Again.
I'll fix that in a second. There. And the line 101 there. Okay, so we're back how we were. So we're going to function.
Yeah. So what we can do now is we can, if you stop this and we reset the time, we take project and you click pause twice.
Yeah.
So what we can do now is we can, if you can create an in the main function we can create an offset like a y offset, right? So we create a float offset. I would do it below this UV.
Yeah.
Hello there, Brandonius. Dinosaur guy.
Brandonius, welcome to the stream. We're making Alf rocket powered.
It's the rocket guy, and we have the dinosaur guy. Let's start with 0.
Okay.
And then we add, you have to show Brandonius how it looks when it's animated. So you click the play here, I think.
Yeah, so we got the rocket plume coming from Alf.
So we're going to
make him fly upwards.
So reset it back to 0. So if you then add this offset on the y-axis to UV, so if you now if offset is 1, if you change that to 1, what happens? Then it starts down there, right?
Yeah.
And if it's -1, it's
there.
Yeah. So what we do is we can make a function. We can make a smooth step function, actually.
Mm-hmm.
Can I borrow it?
Yep.
Keyboard?
Yeah.
So once again, going for smooth stepping. I'm not sure this is the best thing to do, but I'm gonna. That's why I'm going.
Well, we'll try it.
Smooth step is a simple and good function to use. And okay, got the time. And then we go mix, and we start at 1 and we stop at -2 perhaps.
Mm-hmm.
So let's play this thing and see what happens.
Wow. There he goes.
So it's not perfect, right? But it's
It's pretty good though. Pretty good. Let's try that again. I'm not sure what that looks like on stream. Are we getting any kind of?
I think it looks pretty
It looks good, is it? Yeah.
Let's change to 2.5 here and try again. That's good.
It almost accelerates.
Yeah, the smooth type function accelerates, right?
Yeah.
So that's what's nice with.
And now he's gone off the top, which is right.
I mean.
Yeah, yes, it's good enough. It doesn't matter for the cheating. That's absolutely right, Brendan. We're not trying to get it. We could, it is just mathematical functions. It's not actually an animation of fire and smoke. We started with a random noise texture and generated that fire effect and smoke effect with just that random function. So, yeah.
And I think it's possible for us to sort of tweak it to make it look even better. So one thing I'm thinking about that we could do is we could elongate the plume a little bit here.
Yeah.
So I pause here. I think I'm just going to try to multiply or multiply by a number and see what happens.
As always.
Yes. So instead of -2, we multiply by. So that was the wrong direction.
Yeah. Ah.
Let's try that.
Okay. Do stuff. This is the whole process of shaders, Brendan. It's do something, see what it does, change something. Oh god, it was terrible. Change it back. Change another value. Eventually, you get something. Which and that's really well illustrated by this stream. Actually, the way we've managed to get this rocket plume looking the way it has. It was very much trial and error.
It's not much. It's not much sort of I mean, it's a lot of trial and error. This might be a little bit better, right?
Mm-hmm.
I think because the artifact then that we get at the end kind of disappears.
Yeah.
There are ways to sort of improve this, and wow. I think what this needs, this thing here, right, is a little bit of sort of, so it's but that's fixable, right? I don't know. I can fix it, but like maybe a little metal band around. So it looks like it's not just coming out of his. It looks quite strange, but it's more like a part of the picture rather than the flames.
Yes.
So I think that's fixable off stream maybe, and sort of make that happen.
Make around the middle there, just to kind of move that barrier. So there's like almost like it's part of a rocket coming out of him. Yeah.
So you say speed up the plume. You want the fire to evolve fast. Is that what you're saying in Dragon's Eye?
We can give it a go.
Yeah. And that is controlled by the FBM function, if I remember correctly.
It was time, wasn't it, there?
So you multiply by 0.5 perhaps? Like that. Let's see what happens. Yeah, it looks pretty neat.
Yeah. How about that? Is that better, Dragon Eye? How long does that actually take, that whole thing? So try and give an estimate of how long it takes.
9 seconds. The timer is set to 10 seconds.
Yeah. 10 seconds is perfect. So, in terms of controlling that as an animation for stream, how do you start it at a particular time? Because obviously, if it's sitting on a website somewhere, it's running continually. Or do we do it to loop or something? Do we?
Yeah, we could loop it, or just loop it, so it just continues to.
In this case, Alpha should probably disappear off the bottom of the screen a bit, shouldn't he? At time 0, so
could go up and down like he's landing again.
We need to what was that, 5, wasn't it?
No, I think it says that's a weird number.
Oh, it's not the right one. No, it's down here, wasn't it?
I think you changed something here that is not going to look right.
Yeah, that was the wrong thing anyway. It was Alf's position here, wasn't it?
Yeah, so I think you want to change back whatever you changed up there.
I think I did change it back.
Let me see. No, you see it at line 32. It's 0. It's and 0 again.
Yeah.
And try it and see how it looks.
Yeah.
That is fine. Finish. So what you can do now, you can just add a sign function, right?
Oh, right, of course, yeah, absolutely. Sign function to the
rescue. Go down to Rocket here, and this position here on the time. Then what you do is you no, it's in the main function.
The offset, yeah.
So how are we going to do this the best way? Or we just loop it. That's also a possibility. And looping it is quite simple. You just take the mod function around time, and you mod by 10, for example. See what happens. Yeah, I'm not certain this is the best way of doing it, but it's one way to do it.
Mm. So I want to move Alf off the screen at time 0. So I want him lowered down. So,
yeah, so that's the offset, right? You started, if you in the main function here, in the mix, you start from 0.5 perhaps, or 1.5. I said the wrong thing. 1.5.
Yeah, there we go. So it's a bit too low down, I think, now. So
25 perhaps.
Try again.
Now we're into the numbers tweaking.
Yeah. I think that's right.
Yeah.
That's definitely right. I love it.
I mean, it's what is the next step? Is there a next step to do?
I don't know. I think that in terms of getting that onto a website, which we probably should do, how do we deal with the textures that need to be loaded in?
Yeah. So if you remember, the random noise texture is a little bit a challenge, but it's doable. But you know my what's called this this electric elf that I've been doing before.
Yeah.
It uses the electric elf texture. What we also need to do now for this rocket engine to work is either we are computing the cellular noise itself, or
Right.
we are capturing the noise as a texture. And I think they had a new function for sort of saving things. As that's something we can look into. But if we are able to sort of we have SMB as a texture, and we can save the texture as the noise texture as an image, then we can load that into the web page.
Right.
And then we can copy paste this code. So it's not that hard to do it actually. I'm looking at the time though, and I think it might be a little bit tricky to get going in the time I feel I have left in me.
That's fine. We've been going a couple of hours now, so that we can wind up and we can look at that. Get to the that next time if you want. So what's Brendan says?
That is a good continuation, I think, for this stream, right?
I think so. Yes.
So we created kind of something we think, this looks cool. We want to make this into a kind of a web page that you can use on stream, right?
Yes.
And that is something we could continue doing next time.
I think that'd be a good plan.
Yeah, but I actually think surprisingly good this rocket elf.
I think it's fantastic.
Considering we took polar coordinates and just added a few numbers and saw what happened and said, this looks good, and and then randomized a little bit more code. It's almost too easy.
You certainly make it look that way. I mean, and we haven't done anything that new. I mean, all the functions we've used, apart from, but we probably haven't used smooth step before. But all the other functions we've either used or written ourselves. You know, we've done this FBM function we've done before.
That's coming back. Yeah.
We've sampled textures. We've done the polar and rectangular coordinates before.
If you ever do cloud marching, like
we've used that, the ray marching.
That would use FBM as well. So that is just a pattern, you know, that comes back over.
Hyperbolic tangent we've used.
Yeah, love that function.
Yeah, so there's not an awful lot that's new there, but it's a completely different result than we got before.
Yeah, and I actually think the fire looks surprisingly good.
It does look very good. Very, very convincing rocket plume, that.
Yeah, I think the only thing that is a little bit distracting is the bottom.
Yes.
But I think we can...
It needs to be feathered out almost, doesn't it? Rather than expanding so much, it needs to feather out a bit.
We can do something with that, I think. But I think maybe that's a good thing for next stream. I don't know what you think.
I think that's right, because the challenge of going much further with this is that it's probably quite a bit of work.
Yeah.
And we're going to run out of time, so better to stop early and then this could be able to gather thoughts for the next stream and exactly how to do, exactly what to do and how to do them, because there's several kind of tweaks we'd like to do, as well as kind of get it on the web page and then enable it as a seed in OBS. So
yeah,
that'll be a good follow up to this. I think that's a great result to get.
Yeah, and I also think I don't know if there's something you can look in, but the slight modification of the rocket Alf, so it kind of looks like more rocket bottom.
Yeah.
That could be cool, I think.
Definitely, yeah. I'll see what I can do.
Yeah. I think it's a pretty decent result.
I'm very pleased with it.
Yeah.
Thank you so much. You teach me such a lot with this.
Sorry?
You teach me such a lot on this subject.
Yeah, and once again, it's not that we have written that much code either.
No, we're still 121 lines of code, but there's some kind of baggage that comes at the top here, so
yeah,
probably less than 100 lines of code in total.
And also pointing out that we haven't really used any libraries for these things.
No, not at all. No, just a couple of built-in functions. That's all.
The only really library function we used is kind of generating cellular noise, which made the fire look quite nice. That's kind of a library, okay? But other than that, everything else is kind of just mathematics to apply that. And that is also why I like shaders, because it's so you don't write that much code and you get pretty amazing results, I think. If I was seeing this without knowing what I learned, if I was still in my old kind of vector mentality thinking about the world, I would be thinking physics simulation here, right?
Yeah, that's right, yeah.
And thinking, boy, that's hard stuff. Yes, and that is hard.
It's
that's not what we're doing here.
It's a 2D shader, but it's almost got a three-dimensional kind of feel to it, hasn't it? That smoke and fire.
So a lot of cheating to achieve the results. That's okay, I think.
Okay then. So should we finish there then?
I think it's a good point to finish, right?
Yeah, I think so.
And then we take it further a little bit next time.
That's fantastic. Okay, so let's wrap up then. So thank you everyone for joining the stream. We're finishing a little earlier than normal, but I think it's right to stop there when we've got a result, and then we can go away and refine it in the next stream. So that'll be next Monday. So in terms of next stream, I can't do Wednesday because I'll be at work late, so I can't do a stream on Wednesday. But I might try and get something in tomorrow at around about 4 o'clock. So it will more than likely be a Z80 emulator stream. I'll probably work on the debugger, the WPF debugger that I've got. I started work on that over the weekend, and we might try to finish that off. Be able to single step through programs, just like you could with with WinApe, which is the Amstrad CPC emulator that I was using to test some of my code. So that's the plan for that. If it's not that, it'll be a Lego stream. But I'm thinking I want to work on that WPF debugger front end. So we'll do that hopefully tomorrow, if I can get my work finished by 4 o'clock and able to do it. Okay, so let's go and find. Well, the first thing we need to do is make sure we got this saved, and we will. Let's bring it up to. So alpha's in the middle of the screen. There we go. We're going to push this up onto GitHub. So let's have a look what we've got. Codebase Alpha 10 is there. So this is Codebase Alpha 10, the file. It's a Kodelife project file. You'll need Kodelife IDE to actually open it and then play with that shader yourselves if you want to do so. So let's put this into Git.
I think Dragon's Eye, this is going up on the YouTube after a while.
Yeah, so it'll be up YouTube tomorrow, probably about 9 o'clock, 8 or 9 o'clock tomorrow. So yeah, but it will be available on Twitch for the next 60 days as well. So you can watch it on Twitch straight after the stream.
Yeah, my biggest gripe with this Kodelife is that these are binary files.
That's right.
But I love so much about this tool, so I'm accepting that thing. Rocket Alf.
Yeah.
Yes. Alf is going places where no aliens has gone before.
You would be surprised where Alf's been.
Yeah.
But I don't think he's ever launched into space under his own power.
Yeah.
Okay, so that's up on GitHub, so that's available if you want to go and have a play. I think that's great. So if we can just kind of finish that off with a metal band or something, if I can find something suitable to go in that position there, I'll finish it off nicely. Okay, well let's go and find someone to raid, shall we? Go over to Twitch. So who's available to raid, do we think?
Michael Jolly, I watch him sometimes.
Is the Michael Jolly on there? Is he? Well, we'll raid the Michael Jolly. Yeah. Okay then, so thank you so much for joining the stream. Thank you so much, Mårten. It's been a pleasure as always.
Yeah, very fun.
And I'll see you either tomorrow.
Oh,
Mark is sub only, is he? Oh, okay. We better not raid. So he's got so many viewers, he can do that. Okay, that's interesting. So let's cancel that.
Jessica Mark, she does pretty cool stuff. She does shaders as well. She's not.
I haven't got them in my list. So we've got Codephobia.
Lana Lux, she does this. She's a game developer.
Yeah. So should we do Source Scoot? He's got four viewers. We'll give him a raid for some extra people. Okay, so as I say, we'll see you either tomorrow or next week, hopefully tomorrow, for a Z80 emulator stream working on WPF debugger application. So thanks again so much for joining, and we'll see you then. And do stay for the raid and spam that chat with any emotes you've got, especially if you have got any alpha emotes. Let's see plenty of those. So take care everyone, I'll see you then.